Welcome, everyone. It's hard to believe it is week 3 already. So it is Monday morning. I have a cup of coffee and I am raring to go. So I've looked at what we have to do this week, and this video is just going to be an introduction on vectors. It's really fairly easy, and I'm going to add on how to put them in a function. I know that vectors is covered in chapter 4 of Zybooks, but functions are not covered to chapter 5. So this is going to be like going to your supermarket and picking one up and getting one free. So one of the things that we need to include when we're working with vectors is something that we have not included before. So let's start off with our normal way of doing things. So we have include IOStream, and I'm going to put in the using namespace and be looking for a video on an alternative of having to use the using namespace in there, which is not actually good programming, but it does make it easier in the very beginning. So let's go and create our main. Now remember, if your compiler adds some extra things to it, okay, I am back. I had a brief interruption when my wife came in while she was on the phone, so you may have heard that. But anyway, she was just needing to get something from the office. So anyway, I am officially back. So I always start off with something very simple, and then I add on to it. I never make anything complicated. It just doesn't make sense. So I also always add at the end of every closing bracket what the bracket goes to. And you'll see that's going to pay off big dividends when you start doing nested brackets and nested ifs, and you have several functions and you accidentally delete one. So one thing we have to have here is vectors. So we need to include vectors. So now we're good to go. So the very first thing I'm going to do is I'm going to do everything with main, and then the second part of the video, I will take you through the ways of putting it into a function. And we're going to actually do the function two different ways. One that's going to write directly to the vector, and one that's going to pass the vector back as a function return. So this may be new to you since we really haven't done functions, but if you think about it, anything that you do that you use, such as the power function or to upper, to lower, returns a value. So let's go here and create a vector. The way we do that, we just type in the word vector, and in little brackets, you put in the type of vector. We're going to use an integer here, one, but we can do double, we can do string, we can do all kinds of things in here. And I'm going to call it numbers. Now, my personal style of naming vectors is to put a V first and then the actual vector name. Now, I don't have to declare how many numbers are in there because it's going to get added on dynamically. So what we'll do here is we'll create a little loop, and then we'll just say add 5 numbers to it. And then we'll add the vectors, and then we'll print the vectors. So that's fairly simple. So what we're going to do here is write a simple for loop. Now, one thing again, I totally recommend is that you always put your counter, your integer counter, inside the for loop by declaring it this way. Integer I equals, and then whatever you need to start it with, I. So here we're going to do I less than 5, and then we'll do I plus plus. Put a bracket here, and then 4. So this is going to get us 5 integers. A better way to do it would be declare this as a constant, which we're going to do in our next step. So let's go and do a cout. What is the number? And notice that I have a space here, and then a semicolon, and no end line. Let me repeat that. No end line. The next thing we're going to do is get in a integer. Now, we're not doing any error checking in this particular video, so don't worry about it. Problem is, we don't have an integer to get. So let's just go and declare one right here. And I'll call it one number. And I always initialize all of my data types, with exception of vectors, as 0 or 0.0, the blank string, or a blank character. One of the two. So let's go and get our number. And we've got our number. So how do we get it into the vector? It's really very simple. A vector is just like an array. So we can consider doing the numbers of 0 is one number, except for that's not going to work because the numbers right now is empty, and that's the advantage of it over an array. So the way we do it is really very easy. Just type in the numbers, and then I'm going to put the period, and notice all the functions that I have. Now take a look at this size. This is very important. You can't get that very easily in an array. There is a way to calculate it, but I'm not going to go into it now. I know you're probably going to get this all the time. I'm not going to get into it now. I'm not going to get into it now. I'm not going to get into it now. But eventually I will get into it. It's really a very simple way of doing it. You're just getting the total number of elements divided by the size of one element in there. And that gives you the size in there. So let's just not worry about that right now. And we're going to use pushback. So really, pushback is basically the same as stating append to the end. And there also is an emplace back. So I will briefly tell you what the difference is, but for now, using pushback is just fine. So what do we want to do? We want to put back the one number that we had, and we want to add it to the end. So briefly, pushback is going to add a temporary variable where emplaceback does not. So if you have large amounts of data, then emplaceback is better. Pushback is just fine for what we're doing. So now we're going to get this 5 times. So to us to print it, there's 2 different ways that you can print it. So we're going to print it for integer I equals 0. Notice we're starting at 0 this time. Then we're going to do I less than, notice less than, then what we're going to do. Now, I'm not going to put 5 here. I'm going to put the numbers dot size. And notice that I did put less than, and then we're going to do I plus plus. And all we have to do here is print the numbers and just like an array, we're going to do the numbers of I. And we'll do an inline. So let's just do something simple. 1, 2, 3, 4, 5. Hopefully this has worked. Now I am working without any notes. I'm doing this totally on the fly. So you know what happens when you do that. I always make mistakes, but that's good because then it gives me an opportunity to show you how to fix them. So let's go and run it and see what happens. So it says, what is the number? We'll do 1, 2, 4, 6, and now we only got 4 numbers. That doesn't make sense. So let's see what we did wrong. So notice that it says less than 5. Okay, I kind of did that on purpose just to show you that in this particular case, since we're starting 1, we need to get 1 to 5. And because we're not adding it into it using vector style, then we have to start it at 1 in order to get it. So however way you wanted to do it, that's fine. So let's go now and we'll less than or equal to 5, and we'll try this one more time. Now I'm going to always say this till you get sick of it, but I'm going to say it anyway. Do one thing, test it. Do one thing, test it. Do one thing, test it. That's the way you find the step that you made a mistake. So we will go and try it again. 1, 2, 4, 6, and 8. So that takes care of this. So this is nice. So let's just make a little bit of enhancement, which really doesn't have any bearing on this. But this hard-coded 5 is what happens if we wanted to make it 10. Well, yeah, we could just go and make this 10. But suppose we were doing a whole bunch of items and we had 5 all over the place. So what I recommend doing is declaring a constant. Now I'm going to do something that's a little unorthodox, but it's good programming. I'm going to declare a constant, integer, and it's going to be global. So we'll just call it max numbers, and we'll set it equal to 5. Now, there's no danger of max numbers being changed because it's a constant. This makes it available anywhere in the program. As we start doing functions, you'll see how much easier it makes it programming. So now that we have this, we can do max numbers. So we're good here, but now we can do a little bit trick. So what is number? We'll do a little bit of cosmetic stuff in here. What is number? And we'll do I. Notice the space of max numbers. So now it should look a little bit nicer. So now it's going to tell us how many numbers that we have. That's assuming I didn't mess anything up. But now I'm going to change the for loop, and I'm going to print it once, and then I'm going to print it a second time. So let's get a little bit of distance between the two so you can see that it is identical. So we're going to go C out and line just to get a space. And then we're going to do a range-based loop. This makes it so much easier. You don't really need to worry about number size. Now this is actually works, but it's inefficient. The reason being it's inefficient is because every time the loop comes around, it has to calculate numbers.size. So you can argue and say, well, that gets cached or whatever it is. And yeah, but it's better if you were to just have a variable integer size equals v numbers.size. But in any case, we're not going to worry about this because it's going to get eliminated right now. So we're going to do what's called a range-based loop. So we have a magic word that allows us not to put in integer, string, double, float. Remember, if we don't remember what the data type it is, not a problem. We're going to type in the word auto. And then the whatever variable I want to use. Now remember, you cannot manipulate this variable. This is actually what is called an iterator or a pointer to the variable, but we can use it to print. There is a way to actually manipulate it by getting a variable put into it. There is a way, but that's not going to happen in this video. So now what we're going to do v numbers. And then what do we want to do? We'll just do C out. In this particular case, we don't have to do anything but type in num. And we're good. Now, so let's try this one more time. And let's click on it. We'll do 5 numbers again. This time, if we did it right, it should print twice, and they both should be identical. So we'll do 1, 3, 17, 85, and say 125. And 1, 3, 17, 85, 125. So that looks good. So now we don't really need to do this. So let's get rid of this one right over here. So if I wanted to do a string, I would create a vector of type string. So for instance, we wanted to do names. So let's go and create a simple vector. And this time we'll type string. And we'll call it the names. And one thing I want to emphasize is I prefer all variables to get declared on top. That's the best way. It makes your program much more readable, and it also allows for lack of problems. In other words, so easy to make a mistake if you have something declared in the middle. You might not even see it. I also do not recommend ever declaring a variable and initializing it with a function unless under certain circumstances, which I'll actually talk about in the function video. So let's go and run this again. This time, what is the number? We're getting C number, and then we'll do the same thing. C out, and we're going to have an error here. So buckle up, and I will show you how to fix the error. So we're going to do C out, and without doing anything fancy, I'll do what is the name. And then we want to do where if we use cin and somebody has a space in their name, like for instance, Del Toro. So it would be Del space Toro. What would happen is the Del would get put in as the name, a space would be ignored or be in the buffer, but then the Toro would get put in as the second name. So the way you fix that is by using getLine, which gets an entire line of text. Where are we going to get it from? We're going to get it from the keyboard or console in. And where are we going to put it? We're going to put it in a temporary name. So we need another string to call it a name. So let's create one right now. And we'll just call it name, or we'll call it one name. And I'm going to initialize it to nothing. So let's go back to cin, get line, and let's see if that clears up our error. So we have one name, our semicolon, and we have this ugly red line. Now, one of the things that's so great about Visual Studio, I do not know for sure if it does this in Xcode. Somebody that has a Mac, maybe will tell me. If you click this little box over here, it should tell you that you're missing include string. So I'm going to first hold my mouse under this line here and see what happens. Identify and search online, potential X fixes in here. But let's click on here and let's see what it says. So get line in here, add naming space basic in here. So none of these really helps in this particular case. So what we want to do here is just simply add string. The string is included, then the get line becomes available for you. So now we're good in here. So what we have to do is the same exact thing. We're going to do v names. And then we will do, let's see, v names dot push back again. And we'll put in one name. So as an added bonus, let's just do this. Let's just do C out, v names dot size. And each time we add one, what is going to wind up happening is first one will be 1, second one will be 2, and third one will be 3. I had to put the video again on pause. If you heard that in the background, that was somebody calling me. I have a ringtone of theme from New York, New York. That is where I grew up. Currently, I do live in Florida, but I still love New York. Anyway, so we're good here. The V size is in here. If we were to print out V name size or V number size right over here, it's going to print out 0. So let's go and run this right here. And now we'll do the for loop. And notice that we can use the auto again. Let's do auto. And we'll do name. And then we'll do the vector is vnames. And let's go and just do our C out, name, and end line. All right, let's try this one more time, and we'll just go right down. I'll make up names as I go along. So we're going to do one of number 5. So again, we'll do 1, 95, 96, 97. Oh, I'm not, what is the name? So I'm adding it in here. So let me try this again. Let's run this again. And we'll do 95. What is the name? Now, I'm glad I did this because I put in 1. So let me do this one more time, and hopefully you will pick up what the issue is. We'll just do 1. We'll do 15. And what did now notice, look what happens. It says, what is the name? 1. And then it says, what is number 2 of 1? So let's see if we start putting stuff in. Let's do 16. And it says, what is the name? 2. And then, so the issue we have here is whenever you use a get line after a cin, whatever's in the keyboard, which in this particular case is the enter key, is going to be in the, it's going to actually get into get line. I believe the book explained that to you. So what you need to do is you need to make sure that you clear the keyboard buffer. So in other words, if I were to type in 15 and enter, the enter is still in the keyboard buffer. So what would happen is when they get to the get line, it would say, oh, we already have something in the keyboard. We can use that. And it just happened to be the space or the enter key. So let's just go and put in how we fix this. After the get line, what you want to do is cin dot ignore. And I normally do this. I'll put in 100 characters or until I get the new line character. And if you're not sure which way the slash goes, try it one way and try it the other way. So let's go back and do it. Notice that this is in red. So it's going to take it as a character. If it's here, you're going to see it in a nice little purple or maroon, whatever you want to call it, lavender. However, if it works, that's fine. If it doesn't work, then you know that you want to switch it. But anyway, all escape sequences come with a slash that goes down. They call it a backward slash. So let's go back and run it again and see what happens. And notice what is number 5. So we'll do 90. And now it says, what is name? So I'll just do Adam for A, 91, Betty for B, 3, we'll do 95, then we have C, Carol, and we'll do 100, and we're up to E, so we'll do Edward, and then 5, we'll do 150, and let me get a plug of my name in here. All right, so we have 50, 90, 91, 95, 95, and 150. Now this 5 is here, so don't be confused with that. And then we have Adam, Betty, Carol, Edward, and Richard. So we might have a little bit of cosmetic. Oh, this is printing the size of it. That's what was confusing me. So you can see how each time we do it, we have 1, 2, 3, 4, 5. So that is everything for this video. So this should give you a little bit of indication. Then in the next video, which is going to be part 2, we're going to do a way to incorporate this into a function. And what we'll do is we'll create it where you can keep values until you get what is called a sentinel. So be looking forward to that. I have to teach in just a little bit. Monday, Tuesdays, Wednesdays, and Thursdays are usually very, very, very busy days for me, but I will do my best to get the second part of this video to you either out later today or sometime tomorrow. So hopefully this will help. I will also try to give you some insight information on how to do project 1 with the time. If you have not already purchased IntelliSense, then you might want to. That's actually for Visual Studio, the instant feedback, Sense Instant Feedback. You want to do that because that will help you with the clock project. So have a wonderful, wonderful day, and let me know if there's anything that you need, and I'll do the best that I can assist you.